All right, so we are continuing on page 333, where now we're going to go up on the right-hand side and look at how they calculated criterion validity and construct validity. So let's take a look at criterion validity. Criterion validity was determined by concurrent comparison of the respective questionnaires for the sampled group with the total available data pool minus any incomplete responses. So again, taking the patients within that sample size and comparing their questionnaires, because they did all three, minus any responses that were incomplete. So any items on that questionnaire that they did not answer or were not able to answer. And to do so, they used a Pearson coefficient to determine the correlation between the total score of each tool. So, within criterion validity, they looked at, they tested criterion validity for all three outcome measures, and they used a Pearson's coefficient. That is the inferential statistic they used to test for criterion validity. Now let's take a look at what that is. So, Pearson's coefficient is essentially a correlation test. And a correlation test allows an examination of the relationship between variables. Is there a relationship between these variables? And if there is, are they positively or negatively related? And they did that for each outcome measure. A correlation coefficient of 0 means that there's no relationship between the variables. That's usually when you see a scatter plot just with dots scattered everywhere. A negative correlation, a negative correlation or a negative relationship would be -1, and a 1 would be a positive relationship. Now let's see if I can show you an example of what that would look like. A lot of the times you'll see scatter plots such as this. This is when we will generally test, or how we generally, the type of graph, the type of graph that we'll use to test correlation. So when you see dots scattered that are going up, similar towards a line, in this case there are some outliers, but for the most part they're kind of going towards the same direction. That's a positive correlation. So whatever they're testing, hours of spent studying, is correlated by their grade point average, meaning the better grades they get is because of the more time they spent studying. Now if there's a negative correlation, again, we have a few outliers. Outliers are those data points that the numbers are so far or so different they don't fit within that relationship. This was what a negative correlation would look like. In this case, it's number of video games played in grade point average. So the number, however many students they looked at, the more hours they played in video games, it was correlated to having a lower grade point average because they weren't spending that time studying. So there's a negative correlation. Here is what a no correlation will look like. This is 0. So a negative correlation is -1. Positive correlation is 1. No correlation would be 0. And in this case, it is size of television and average time spent watching TV a week. Essentially, it doesn't matter what size TV you watch and how many hours you spend watching that TV. So that's correlation. And that is another inferential statistic that we use. This is useful when you're looking at criterion validity because you're assessing that relationship of the responses per outcome measure that was used. So let's go back to the article. So for criterion validity, they looked at the relationship of, or correlation or relationship of responses in each outcome measure, the total for each outcome measure that each patient was given. Now for construct validity, Construct validity was investigated in 3 methods. The distributional analysis of responses was performed to determine the presence of Gaussian or a bell-shaped curve. If you remember, a bell-shaped curve means normal distribution, or skew or bias towards a floor or ceiling effect. And floor and ceiling means either the test is too hard or too easy. In either case, we don't want that. The distribution analysis of responses was performed to determine the presence of a Gaussian or bell-shaped curve, skew or bias toward a floor or ceiling effect that included with limb components in a comparison of proximal versus distal means, the latter expected to be higher, thus showing greater functional loss. So, looking at the components of upper extremity, right? And determining if there's a normal distribution. That was one. The responses were considered in 10 categories with a single category for each of floor and ceiling scores, respectively. Categories 1 and 10. The remaining 8 categories were whole number groups from the individual scales, groups of 15 points and a final group of 14 points, ULFI, groups of 3 points, the UEFS, groups of 8 points, a final group of 7 points. In this way, distribution can be related to an approximated normal or bell curve indicated by the distribution. Data response and distribution within the 4 kinetic chain components of the limb were also investigated, distal being the wrist and hand, central being the forearm and elbow, proximal being the shoulder and the upper arm, 4 general being those conditions that affected the whole limb, complex regional pain, syndrome, and lymphedema. This method indicates the presence or potential for skew or bias to the component of the limb via comparison of the distribution, both range, type, as well as the proximal versus distal. So they're giving you a little bit more information. We're getting to the rest. They also used the known group method, compared initial and final scores from a period of known natural healing with expected improvement. So for that, they just used a simple t-test at a confidence interval of 95%, comparing the prospective subgroup measurements that were used. The subgroups were the patients, and they used a t-test to compare their initial scores they compared their initial scores and the final scores from the period of known healing with expected improvement. And that was also based on a 95% confidence interval. Response severity order is a new concept which ranks the mean item score to reflect the order of severity or incidence of impairment, and is maintained by calculating the mean score for the individual items with the total of the data pool. I won't go into detail about this because in this case they're just providing you with more information. So essentially they used 3 methods. The 3 methods are: 1, distributional analysis of responses, where they used the Gaussian or bell-shaped curve, so they looked for normal distribution. The second method was the known group method, where they compared initial and final scores from a period of known natural healing with expected improvement based on the 95 confidence interval. And then they also looked at response severity. So for that section, what I really want you to understand is that there were 3 methods used to determine construct validity. They were response severity, the known group method, and then they also looked at the Gaussian or bell-shaped curve, looking for normal distribution of responses. All right. Whew. I know we're addressing a lot, but we're just kind of talking about what they're seeing. Now, earlier I talked to you about what responses were, and within this article, they also assessed for missing responses. So, if you remember, responses are the patient's or the subject's answers to those items on each questionnaire. There are a certain amount of responses that are often allowed to be missed, and that's calculated into the total score that was looked at for the DASH. So I'm going to go back up to page, if it doesn't freeze on me, before they talked about the different phases. When they started discussing stage 3 on page 331, and they explained to you what the different outcome measures were, the UEFS and the DASH. They told you that within the DASH there were a certain amount of responses that could be missed when they were describing to you what the DASH was. The raw score is recalculated for expression on a 100-point scale by subtracting 30, then dividing 1.2, and allows for up to 3 missing responses by adding the number of missing factors. And they continue to talk about what it was. Essentially, what I'm trying to say is that the outcome measure includes or adjust for missing responses. Okay. So each outcome measure will adjust for missing responses. Now, within this article, they assess for missing responses in total as well. So now I'm back down to page 334, and this is right before we get to the results. They talk about missing responses. So as we read on page 334, missing responses are anticipated in all self-reported outcome measures, being noted as not applicable or left blank in Likert form scale tools. Which means that within that self-reporting outcome measure, a patient either just simply did not answer that item or that question. And I'll go back to an example. So looking at the upper extremity functional index, if a patient were to just not answer question 1 at all, or that would be a missed response. Or in a case, let's see, does the DASH have any? Or if on some aspect of the DASH where they just didn't answer it or they put not applicable, that would be considered within the missed responses. We have to also assess for that. So missing responses are anticipated in all self-reported outcome measures, being noted as not applicable or left blank in Likert format tools. There is an acceptable limit of up to 10% of total available question items. If the number of missing responses exceeds this limit, the questionnaire is considered invalid. So, essentially this is saying that if a patient misses more than 10% of that outcome measure, they don't answer 10% or more, the questionnaire itself is considered invalid. Okay? They're not using it. The missing responses score is accounted for the addition of the mean of the remaining item scores for each missed response, and it is used to calculate the final score, as in this case for both the DASH and the UEFS. Okay, so they're just kind of talking to you about how they address missing responses. That's important because you need to assess for that as well. Responsiveness, defined as the ability to detect meaningful change over time when it has occurred, has also been referred as sensitivity to change. It is not a fixed property of an instrument and consequently argued as not always being the most critical. Okay, the essential statistics used are standard response mean and effect size. These are defined as SRM is the mean change divided by the standard deviation of change scores. Effect size is the mean change divided by the standard deviation of the baseline scores. Now let's talk a little bit about effect size because it plays an important part, and we are also going to see it in some of the graphs.